Hello and welcome to this screencast which explains chemical and magnetic equivalence in proton NMR spectra. Chemical equivalence depends on the location and relationship of atoms to other atoms in the molecule, whereas magnetic equivalence depends on whether nuclei couple to other nuclei in the same or different ways. The protons in methyl groups and most methylene groups are said to be chemically equivalent, as they have the same relationships to other atoms in the molecule. In the example of bromomethane, on the left here, all three hydrogen atoms are one bond away from the carbon and two bonds away from the bromine. In bromoethane, on the right, the methyl protons in blue are all one bond away from the methyl carbon, two bonds away from the methylene carbon, and three bonds away from the bromine. The methylene hydrogens are all one bond away from the methylene carbon and two bonds away from the bromine. Therefore, the methyl hydrogens are chemically equivalent to each other and the methylene hydrogens are chemically equivalent to each other, but the two groups of hydrogens are different from each other. Each one of the methyl protons in bromoethane couples in the same way to each one of the methylene protons, meaning that they are also magnetically equivalent. In some systems, particularly aromatic rings, protons may be in the same chemical environment due to symmetry, but because of constrained geometry, do not couple to other protons on the ring in the same ways. We describe such protons as chemically equivalent, but magnetically inequivalent. Let's look at an example. In the paradisubstituted benzene shown here, there's a plane of symmetry through the middle of the molecule. This means that protons A and A' are in the same chemical environment as each other because they're both ortho to the nitro group. In the same way, protons B and B' are in the same chemical environment as each other because they're both ortho to the chlorine atom. However, if we look at the couplings of HA to other protons, we can see that they're not the same. HA couples to HB with an ortho coupling constant of around 8 Hz. HA couples to HB' with a para coupling constant of less than 1 Hz. Therefore, protons B and B' are chemically equivalent, but magnetically inequivalent to each other. The signal from HA in the proton NMR spectrum will appear as a doublet of doublets, because it has both ortho and para coupling constants to the B protons. Thanks for watching, and look out for more resources coming soon on the Analytical Science Tutor channel.